Okay guys, today what we're going to do drawings to model and determine equivalent ratios. We're also going to do some tape diagrams to model and determine equivalent ratios. So that's our two big focuses for today. Our next lesson we'll get into the rest of what we've got here. Homework, really simple, just what the next Mathia workspace. You'll be at number 32. This one is the introduction to double number lines, which is what we'll be doing next class period. Yes? Couldn't hear a word. Okay, I'll try to print you out a copy. Liam, you had a question? Okay. Okay, our first problem today. Let's go to the next. Open up your modules to page 193. Here again are our learning goals. Our focus today is going to be on some of these drawings to help you reason through ratios and equivalent ratios. And then we'll start talking a little bit more about rates. The first warm-up should be pretty easy. I'm only going to give you guys like a minute to work on this together. Just answer these two questions, but make sure you think about your reasoning behind your answer. Okay, these first two guys should have been pretty easy. On our first one, these are all based on it takes 5 workers to paint 3 houses in a day. So painting fewer houses with more workers, which one of those is it going to take? Sophia?
It's going to take less time.
Why?
Because if you have fewer houses and you only need 5 workers for each house, and you already have a whole bunch of extra workers, they can move on to other houses, and then they can get it all done.
Good. So it's really hit both sides of that ratio, right? Mm-hmm. I dropped the number of houses, so I have less to do, but I even added more. So that's really going to change that overall, right? Painting more houses in a shorter amount of time requires, yes, more workers. Explain your reasoning. Okay. Good. Because I'm now adding more houses and I want less time, I'm going to add even more workers, right? So I need to actually get beyond that 3 to 5 ratio. We're going to add more workers than that to get it equal and make it less time. Okay, let's go ahead and go to the next page. This is 194. There are 5 questions, 4 questions. I want you to look at each one. Consider given representations. Here's our key. Explain our reasoning. I'm going to add one in here for you as well. Write the ratio for each picture. Because that's going to give you a good basis to start your reasoning on. Make sense? Okay. I do want you guys to take your time on this, and especially on the reasoning piece. So I'm going to give you guys like 7 minutes to do these 4 problems. Go ahead and start. You will work together as a table. Okay. So we had 2 parts on this. First part was to write the ratios. Second part was to answer the questions that were being asked. So which dinner order has more pizza? If we start with our ratios, it should make this easier, right? So on my first one, I have 3 pizzas, 2 hamburgers. For the second one, I end up with 3 pizzas, 2, 1 hamburger. Okay? So, which one had more pizzas?
Equal.
Are you sure? Guys, hold on. How many of you think that order 1 had more pizzas? How many think order 2 had more pizzas? How many of you think they had the same amount? Okay? So, someone that raised your hand for more pizzas. Can you explain why? Shh, guys. Okay? So, for those of you that couldn't hear him, what he said was, this one had 3 pizzas to 1 hamburger, this is 3 to 2. So if I made that 2 hamburgers, we would have 6 pizzas. You guys remember that whole experiment we did the other day about the 2 fruity versus 2 gingery? Okay? That was your homework. So apparently Angelina didn't do her homework, but most of the rest of you got it. She didn't remember it, so I was assuming she didn't do her homework. Guys, so what kind of reasoning is this? This is actually multiplicative. So if you looked at this as multiplicative, in other words, I wanted to get the same amount of hamburgers to be able to compare the pizzas, you would have said order 2 had more. If you looked at this from an additive standpoint, in other words, I'm just looking at comparing the numbers, then you would have answered that they were equal. So you could have had either answer and justified it. If I used additive, I would have said equal. If I used multiplicative, in other words, finding the same amount of hamburgers, then it would have been order number 2. So either one of those could have been a correct answer. For those of you that said order 1 had more, sorry, I can't really get a good justification on that one. So that should help set you up for number 2. This one we had 4 stars to 2 triangles. And in our second one, we had 3 stars to 3 circles. Which one had more stars? How many of you voted for number 1? So number 1 has more stars. Okay? How many of you said number 2 has more stars? Okay, we have a lot of people. We must have had a bunch more equals. How many thought it was equal between the 2? We had an awful lot of people not vote. So let's try this again. How many of you said pattern 1 had more stars? Now all of a sudden we're there. Okay. So, guys, honestly on this one, there's no way to get past order 1. Because if I look at it from an additive standpoint, in other words, I just compare, then it's going to be pattern 1 because it has more stars. If I look at it from pattern 1, from a multiplicative standpoint, in other words, I find out where they have the same, this one actually simplifies to 2 to 1. This one is 1 to 1. So if I'm comparing to one of the other, pattern 2 is still, or pattern 1 is still the most stars. Okay? Our third one, which pile laundry, has more shirts. This one we have 2 shirts, 2, 3 pants. Guys, please stop the background noise. Our second one we have 2 shirts, 2, 4 pants. Okay, how many of you chose pile 1 having more shirts?
Everybody vote.
How many voted for pile 1 having more shirts? Okay, hands down, how many voted for pile 2 having more shirts? How many of you voted that they were equal? Interesting, okay. So, once again, if I want to compare to the same amount, if I get 4 pants and 3 pants, where would that meet? Where would I find the same number of pants?
No, like 1, 2.
12, right?
Yeah, 12.
So I would multiply this by 4. That would give me 8 shirts to 12 pants. I would multiply this one by 3, gives me 6 shirts to 12 pants.
Like how you get a fraction.
So, which one would have more? Pile 1. But if I looked at it from an additive, in other words, if I just look at the numbers they gave me, additive, they would be equal. Multiplicative, if I find a common comparison, then it's going to be pile 1. So the bottom one, if you did like I did and just put your reasoning on the problem, that's fine. Just make sure you had some explanation as to why those added up. Any questions on what we did on this first page? Okay, let's go ahead and turn the page. We're on 195. Take off the hood. Thank you. On this one, Carrie and her friends are going hiking. Carrie invites her friends to meet her house for a quick breakfast before heading out. She wants to offer yogurt. She knows that one yogurt pack has 4 yogurts that can feed 4 people. Watch this. Draw a model to answer each question. Explain your reasoning. So what are we supposed to do for every problem here? Draw a model and explain your reasoning. Does everybody understand what you're to do?
Yes.
Why not? You know how to draw a model? If I were to draw 4 yogurt cups, what would it look like? If I were to draw 4 people, what would it look like? Personally, I would use stick figures, but if you're a good artist, you may get more intricate. But keep it simple because time is of the essence here. Understand what you're supposed to do? Okay, guys. You have number 1's got 3 parts. So you have 3 questions to answer. You need to draw a model, explain your reasoning. I will give you guys 7 minutes to do these 3 problems. Go. Okay, we had to draw a model and explain our reasoning for each of these. So I'm going to do a very simple model because I am not an artist. So we're going to start with what is the relationship between the yogurt pack and the number of people it will feed. In other words, let's make a ratio. I can start with my model. I know that my yogurts come in packs of 4, and I know that each yogurt feeds 1 person. So my model would look something like this. I know your guys' artistic skills may not match mine. It might not look quite that good, but at least you can get the concept, right? So I could start it and say I have 4 yogurts to 4 people. Can I simplify that?
Yeah.
Yeah? Down to what?
1, 1.
1 to 1. I can divide those both by 4, right? So I could say 1 yogurt to 1 person. Is everybody okay with that? Okay? If Carrie invites 6 friends, how many yogurt packs will she need? So if we do our model again, I've got, again, they're in packs of 4. So I have this one with my 4 people. And then my next pack, how many do I use? 2, because I only have 6 people, right? Carrie's included.
If Carrie invites 6 friends, you'll have 7.
Actually, that's good reasoning. I'd take that. So, including her, and I would take either answer on this. So in this case, what do I have?
1 and 3/4.
1 and 3/4. If you did Carrie included as the friends, that would have been 1 and 2/4, which I could simplify, divide that by 2 to make 1 1/2. Okay? Well, on this one, Carrie also needs 1. On this one, just includes the friends. Okay? Our third part if Carrie has 2 3/4 yogurt packs, how many friends can she feed? So in this case, our model should help us again. If I do 1, 2, 3, 4, there's 1 pack. There's our second pack. And then in our third pack, we only have 3 of the 4, correct? So, how many friends can she feed? So again, it depends on how you're looking at it. If you're counting Carrie as one of the people that she can feed a total of 11. So that would be 10 friends and her. Okay? So, is everybody understanding the reasoning on these? Seeing how our ratios are changing based on how we're looking at them? That's really that first concept, right? Guys, So our first part was, am I looking at this from an additive or multiplicative standpoint? Down and hood down. Seriously. This one is, am I including Carrie as a friend or not? So how you're looking at it can change your reasoning. Make sure you're fully explaining yourself. Now let's do a variety pack. So in one yogurt variety pack, 2 out of every 5 yogurts are blueberry. And in the picture, they show us what the other one is, right? Strawberry. So, again, we're drawing a model and explaining our reasoning. So this one, we've got 3 parts again, A, B, and C. That was fun. Okay, so go ahead and do A, B, and C. We got 3 problems. I'll give you guys like 5 minutes to finish that one off. Started on recording. I'm going to introduce you guys to a model that we'll be using for these ratios. I'll be honest, when I first started teaching Engage New York 5 years ago, the first time I saw this lesson, I was like, I've never heard of this, I'm not even doing it. But then as I gave it a chance, I was like, this is actually a really cool thing. So, the cool thing I'm talking about is what we call a tape diagram. I can't remember, someone over here asked me, they're like, well, can't I just use like BY and SY so I don't have to write blueberry and strawberry for all 3 problems? You can, but you need what we call a key to show that, right? So I can say B is the number of blueberry yogurts. And S is the number of strawberry yogurts. And now, for all 3 problems, all I have to do is write down B and S, and I now know what they stand for, right? But if I just start writing B and S all through this page, do I know what that is? No. No. So the big part here is make sure you have a key or a legend to show me what you're using to identify your variables. Once I've done that, now we can make this really easy. Watch how this goes. So for the B, I've got 2 boxes. For the S, I have 3 boxes, right? Okay? But they have to give me more information if they want me to figure something out. I have to have a 3rd piece of information. In this case, the 3rd one they gave me is, there are a total of 25, but here's my question. How many are blueberry? So we need to make sure we're answering the question that's asked, right? Now, this gets us to another term, and I want you guys to add this in, because you're not going to see this anywhere. I actually made this up 6 years ago when I was doing these, and I was like, I need to call this something. And that something is what we're going to call a ratio constant. Please add this in your notes. You're not going to see this, you're not going to know what this is, unless you write it down. The ratio constant is the number inside the box of a tape diagram. And we'll get to the tape diagram definition in a minute, because they actually do have that in the book, but they don't have this definition. So what I'm saying is, if I have a ratio, and I know it's 2 blueberries to 3 strawberry yogurts, my tape diagram, I just do 2 boxes on top for the blueberry, 3 boxes on bottom for the strawberry. I now have my ratio shown in a model. But they gave me that third piece of information. They said there's 25 total yogurts, right? So that's the information I need to find my ratio constant, or the number that goes inside of each box. So because they gave me a total, how many boxes do I have total? No. Guys, you can look at the picture and count. 5. So I have 5 boxes that represent 20 total yogurts. So what number would go inside each box to get me to 20? What number would go inside each box to get me to 20? 4. Because if I have 4 boxes, 4 inside each box, and I have 5 boxes, that gets me to 20 total, right? That number 4, that's what we call the ratio constant. The number that goes in the box to show my total. Now that I have the numbers inside the box, can someone tell me how many blueberry yogurts I have? Stop. Yes. 2 boxes of 4, right? So that equals 8. So my answer is there are 8 blueberry yogurts. Does this make sense to everyone?
No.
Thank you for being honest. Why not? Oh, good job. I was going on another one where it was 20. So what would I need to put inside for my ratio constant? 5. So if I put 5 in each box, I'm going to have to just redraw them. So now, that's where the 10 comes from. Does everybody understand it now? Everybody see the difference? Okay? You have to realize what they gave us. They said 25 total yogurts, meaning I needed 5 in every box to get there. Everybody tracking now? Okay. Let's try it again. How many yogurts are blueberry when there are a total of 35? So we can start with our same tape diagram. 2 boxes on top, 3 boxes on the bottom. My ratio constant has now changed though, hasn't it? Because instead of 25 total, it's 35 total. Meaning my new ratio constant is what? 7. So a 7 goes inside of every box. And here's the other thing, guys. Once you find the ratio constant, there's a reason it's called a ratio constant. Every box gets it. So if you found it for 1 box, every box gets it. That's a really nice thing on these tape diagrams. And now again, I want to know how many blueberries there are. So I put those together. 7 and 7 gives me 14. So there are 14 blueberry yogurts. Then our last one. So we start with our same diagram because our ratios haven't changed any. So we've got, oopsie, 2 to 3, not 4. Blueberry, strawberry. But now I know how many total is what I want to know when 8 yogurts are blueberry. So here's where I got to start getting a little more specific. They had to give me that third piece of information, which is 8 are blueberry Chair down, that's second warning. Meaning my ratio constant is, Austin? 4, because there's 2 boxes for blueberry yogurts. Does that make sense for everybody? Mm-hmm. So 2 boxes, to get to 8, I would need to put a 4 in each of them. And again, my ratio constant, once I know one, I know all of them. So now I know I have 5 boxes with 4 each, so how many total yogurts do I have? That's where the 20 came from problem 1. I was thinking back to this one. Are you guys seeing these patterns? Can you see how the tape diagrams can be beneficial? Yes. Okay? They're actually very easy. Go ahead and pull out your highlighters. We've got a definition here. Highlighters or colored pencils, whatever you're using to mark your text. Sure. Okay, we're going to talk about equivalent ratios. They represent the same part-to-part or part-to-whole relationship. I'm going to have you add to this definition because there's a part I feel they're missing on this, and that is equivalent ratios. Simplify to the same number. So if I reduce a ratio to simplest form and it becomes the same, that means they're equivalent. They go to the same number. Another way to look at it is if I have a simplified ratio and I multiply both pieces of it by the same number, I will get an equivalent ratio. Yes? Sign out. Good. Everybody have those definitions down? Okay, let's go ahead and go to our next page. Okay, we're going to do another one. We have a variety pack of blueberry, pumpkin, and bran muffins. They always sell the muffins in a ratio of 3 blueberry to 2 pumpkin to 1 bran. So we're going to write the ratio that expresses each relationship. So we have to do this part. And we have to identify as a part-to-part or part-to-whole ratio. So we have 2 parts to all of these, right? Does it say anything about modeling or tape diagrams?
No.
So do I need any pictures?
No.
Nope. So all I'm doing, guys, write the ratio. And I do want you to simplify the ratio if possible. And then tell me is it part-to-part or part-to-whole. There's 6 of them here. This literally should take you guys about 3 minutes. So go ahead and get to work. Our first one, blueberry to total. So if I go back up, it was 3 blueberry to total of 6. That would simplify to 1 to 2. And that would be a part to whole. Because I'm comparing the piece to the total of them. Pumpkin to total, that would be 2 to 6, simplifies to 1 to 3. This again would be a part to whole. Bran to total, now we're at 1 to 6. That one I can't simplify any further. That is another part to whole. So I'm comparing it to the total of muffins. Blueberry to pumpkin, 3 to 2. This one is a part to part. I can't simplify that anymore, so we just leave it like that. Bran to pumpkin. Bran was 1, pumpkin was 2. This is another part to part. And I can't simplify that. Those are both in simplest form. And our last one, blueberry to bran. That is a 3 to 1. If that was a fraction, technically I'd say to 3, but I can't because remember, in a ratio, I always have to show 2 numbers. This one is another part to part. Okay, quick thumb meter. How are we doing on those? Everybody, thumb meter. You haven't heard the thumb meter? You're doing well. You're kind of questioning. You did bad on this. Okay, looks like Tita, is that to the side? Or is that up? Okay. Our second part. Here's where we need our highlighters / markers again. Here's where they're giving you the tape diagram definition. So a tape diagram illustrates number relationships by using rectangles to represent ratio parts. So all it is the number of boxes for each part of the ratio. And then the piece that we put inside is what we called our ratio constant. So this is a good one because I can now represent my entire ratio with just the boxes. So the tape diagram represents the ratio of each type of muffin. What does each small rectangle represent in the given tape diagram? So if I look at this, what does each rectangle represent? Yes? Each box is one muffin. Good. So each box is one muffin. And that's going to bother me. I should have capitalized that. Does that make sense to everybody? That's why I have 3 to 2 to 1. So I can do even a more complex ratio with 3 numbers in it just by showing the number of boxes in each. Okay, next we're on page 198. Now, suppose I do an 18-pack of muffins. How many blueberry, pumpkin, and bran muffins will I purchase? So there's our question. So there are 6 muffins represented in the tape diagram. I want 18 total muffins that are in the same ratio. Therefore, to determine how many, to maintain the same ratio, you can divide 18 by 6. That gives me 3. Who remembers the term I made up that 3 represents? The vocabulary term? Calvin? Awesome. Ratio constant. Meaning that 3 goes inside every box. So I have a 3 inside every box. That now shows that we have 18 muffins. Make sense for everybody? Anybody struggling on that part? So from that, I can then see 3 plus 3 plus 3 means I have how many blueberry? 9. 3 plus 3 means I have how many pumpkin? 6. 3 means I have 3 bran. So can you see where those numbers come from as well? And if I add that up, 9 plus 6 is
9 plus 15.
15 plus 3 gives me my 18 pack of muffins. So, is the ratio 6 to 9, 9 to 6 to 3 equivalent to 3 to 2 to 1? Yes. How do I know? Yes. Awesome. I love that. I can divide 9, 6, and 3 by 3 to get 3, 2, and 1, meaning they are equivalent, because that is the definition of equivalent. They simplify to the same number. Does that make sense for everyone? Again, the whole key is if I simplify them to the same number, they are equivalent. That's your definition of equivalent ratios. So use our tape diagram to answer each question. So they're giving us a couple of different scenarios. I want you guys to work together. I'm only going to give you 3 minutes, but you should be able to answer these pretty quickly. Focus in on the information they've given you and how it relates to your picture. Okay, guys. So this one, hopefully you broke it down quickly. So I have a 36 pack of muffins. How many blueberry, pumpkin, and bran will I receive? So 36, I have 6 boxes, makes a ratio constant of 6. So I put 6 in each box. gives me 18, 12, and 6. So there are 18 blueberry, 12 pumpkin, and 6 bran muffins. Suppose you wanted 20 pumpkin muffins in your variety pack. How many total muffins will be in your value pack? So now is where it gets a little more specific. So basically, pumpkin I want to equal 20. Means I have a ratio constant of 10. With my ratio constant of 10, means I will have 60 total. Can you guys see how the tape diagrams can make this easy? Honestly, drawing boxes isn't hard. Okay, we're going to run through this together because we're down to 2 minutes. So, we need to complete the missing cells for the 6-pack and 36-pack. That should be an easy one. For the 8 to 36, all I'm going to do is double all those numbers, right? So that becomes 18, 12, and 6. Going from 18 to 6, I'm just going to divide by 3. So that gives me 3, 2, and 1. So what do you notice about those? They're all multiples of each other, right?
Yeah.
Okay? So, they are all multiples. Then, now, if I've done that, can I now fill in the 12 and the 24? Yes. Because I go 6 to 12, what do I do? Times 2. So I just multiply by 2. 6, 4, 2. So I have 2 choices now. I can go 12 to 24 or 6 to 24. Either way, I get times 4, 12, 8, 4. Okay, just one math here for tonight, guys.